Welcome to problem 1099, 2 sum less than k. We'll read the problem real quick. Given an array A of integers and integer k, return the maximum s such that there exists I is less than j with element I plus element j equals s and s is less than k. If no I and j exist, satisfying this equation, return -1. So that was a mouthful to basically say find 2 elements in this array which maximum sum has to be less than k. So here's an example, right? We have an array of a bunch of elements and the k is 60. So the maximum sum of 2 elements in this array that is less than 60 is 58, meaning that there is no sum that exists in this array that is less than 60 and greater than 58. So 58 is the max. Now, how could we go about solving a problem like this? So the very first thing I would think about is brute force, right? So what is the most simple way you can think about this on top of your head to solve this, right? The brute force is what we call it. Now, what comes to mind is let's compare every element except to itself, right? That way we can get all possible sums. So doing so, if we can get all possible sums, we know that in one of those sums, there exists a sum that is the maximum of less than 60. And if in the case that there isn't, then we could return -1, meaning that there is no possible sum that is less than k. And how could we go about doing that, right? A brute force that comes to mind is having 2 pointers, I and j. Where I, we start off at 0, and j is, we always start where is I plus 1. So the reason why I would start it this way is because we can get every possible sum except the sums that you compare the same element twice, which we won't do in this scenario. We would do something like this. We'd keep I anchored, and we would move j to the right until we hit the end of the array. So we go, and let's have another variable here for demonstration purposes called max. So we'll do I plus j. So in this scenario, 34 plus 23 is 57. And then we move j over. So then we go 34 plus 1 is 35. Well, 35 is not bigger than our current max of 57, so we keep going. And we go 34 plus 24, well, that's 58. That's definitely bigger than our current max, so we update our max, and we keep going. And we're going to keep going all the way till we hit the end of the array, and then we're going to reset I, where we increase I to the next number. And then we compare we add 23 to every possible number to the right of it. To 1, to 24, to 75, to 33, and then we keep doing that, right? And we're always checking at every iteration, we're checking if that sum is greater than our current max. And doing so, you would have compared every possible number until j hit the end of the array. When j hits the end of the array, this is where we exit out of the for loops and we return the max. And in this scenario, it would be 58, and 58 indeed is less than 60. So what kind of pseudocode would this be, right? So we have I and j. So we would have to have one for loop that controls I, and we have to have another for loop that's nested, which controls j. This type of setup would be a running time of n squared. So there's always, somewhere out there, there's always a better solution, but given this particular problem, I think n squared is suffice. So let's code this up and see if we pass all the test cases and how we compare to the other submissions. So let's do that now. Cool, so let's get to coding. Dope. So the very first thing I'm going to start with is the max, right? This part. If we can't find it, return -1. So we'll start off max at, we'll do let max equals -1, meaning if we can't find a max that is less than k, then let's just return max, which will be -1 in this scenario. So here's where we start with the iteration, right? How do we set up our pointers of I and j? So we do a for loop where let I equal 0, right? We always start at I in the beginning. For demonstrational purposes, get this back in here. So we want to start I right here. So 0. Cool. So then we'll do I is less than a dot length. Let's do, yeah, a dot length. And then we'll do I plus plus. Oops. And then we now want to set up our j. So for let, so we said our j is always going to start at next to I. So we can do this. We could do let j equals I plus 1, meaning j would always be 1 ahead of I. And we're going to do while j is less than a dot length j plus plus. Very cool. So here comes the part where reading the problem is very important, right? So the problem is saying that in order for us to update the max, we have to satisfy where the sum is less than k, right? K. And for this example, k is 60. So we can get the sum, the current sum, by doing something like this. Let's do cur sum equals a element at I position plus the element at the jth position. So now we would do if the current sum is less than k, right? Satisfies what they're asking in this scenario. And max and current sum is greater than max, which we really need both of these parts because we want it to satisfy that is less than k, but we also want to make sure that we're updating our max every time, right? So if both of these are true, we're going to update our max. So max equals current sum. And then once this is all over, we can return max. So again, going back to this example, we're saying if there is no sum that is less than k, then we could return -1, right? But because we're setting up max to be -1 anyway, we could just return it. So let's kind of go over this real quick. So we're going to compare 34 and 23, and that's 57. So we're going to update, and that's true, right? 57 is less than k, and 57 is greater than our current max, which is -1. So we update our max to be 57. And then we keep going, we keep going, we keep going. And once we get to 24, that's when we would basically say, is 34 plus 24, which is 58, is 58 less than k? Yes. Is 58 greater than our max, which is 57? Yes. So then we would set that up. We would go through every one and find out that, yes, max, our current max for this specific example is 58, sorry. So then we return that. And I think this solves our problem. Let's see if we pass all the test cases. Let's hit submit. Awesome. And just like that, we have a runtime of 60 milliseconds, which is faster than 78.64% of JavaScript online submissions. That's awesome. So I hope you guys liked it, and I'll see you guys at the next problem.